So I'm going to kick off. Christabel Brand had to withdraw at the last minute, so I threw something together very quickly on Friday to cover off some practical applications of portable XRF in mineral exploration. So really, would like to start with a philosophical positioning, if you like, about different ways to go about doing portable XRF in the field for mineral exploration techniques. Basically, we can go fully quantitative, but you're going to have to calibrate your instruments. You're going to have a fit-for-purpose QA/QC program. You're going to have to give some thought to sampling, because the sampling problems don't go away simply because we're using portable XRF. And I believe you need to do some verification using laboratory analysis. Or we can go purely qualitative. So a real simple QA/QC program to monitor instrumental drift. No calibration of the instrument necessarily, because we're looking at relative differences in concentrations. Perhaps minimal sample preparation. You can see a photograph on the side there of a soil sample in the sample bag directly placed on a portable XRF instrument, a benchtop. So we can analyze directly through the sample bags. So the first project I'd like to talk about is one that we published a few years back. This goes back to when I was working with Revelation Geoscience in northern Canada. An early stage gold project. Key points are we sampled sea horizon soils. It's actually an area of residual soils in the Yukon of Canada that was not covered by the most recent glaciation. So the soils are effectively in place. You can use them to interpret bedrock geology. We had just over 14,500 samples. These were analyzed using two different portable XRFs because of the sheer number of samples coming through. We actually mixed instruments, which is generally not advised practice, but in the field you do what you have to do to get the job done. But the samples, kilogram samples, also went off for sieving. We used a minus 150 mesh sample, and a 30-gram aliquot was analyzed by ICP-MS. The results are that we had very good agreement for arsenic and copper without having to do anything to the data from the two instruments. I did have to do some leveling for lead and moly and nickel data. And other elements, the detection limits were too high to really give us useful data. So take a look at these two diagrams. One of them is ICP-MS arsenic data, and the other is portable XRF data taken off two instruments. I challenge you to spot the differences between those two plots. I'm presenting the data as gridded percentile images. So if you look at the scales, the absolute numbers are a little bit different, but really we're looking at the upper and lower percentiles of the data. So we're looking at relative differences. We're not really concerned about absolute values at this point. So the data from the portable XRF we were able to generate during the field program, and we would have that data coming in probably about a week after the samples were collected. Now the other case study I'd like to show you is one that I did while working for CSA Global. And that's physically scanning diamond drill core, in this case for copper, by dragging the instrument across the core just to see if we got better results than if we did spot analysis. You have to make sure that you keep the instrument beam on one setting, so you can only have one filter or one beam operating for the elements of interest. You need to lay out your core properly, and you have to scan at a constant rate. This is now done through robotics, but this was really just an orientation study done a few years ago to see if it actually worked. And you obviously need to stay close to the core surface. So what we found looking at drill core from a number of porphyry copper deposits in North America was that The spot sampling really struggled to give representative data, so we were comparing the data to 4 acid copper assays. But what we found was doing multiple scans with the instrument on the core, we were able to get fairly accurate and reproducible results. And then we had some situations where we had high-angle veins in the core that we simply couldn't analyze using the XRF. So you have to remember, with the XRF, you're only analyzing the surface of the drill core. So here are the results. So I'm plotting accuracy as bias of the portable XRF data against the laboratory assays. And you can see that we only get that bias down to close to 0 after doing about 16 spot analysis, so that's 16 times the 30-second count time. Whereas with 3 drag analysis, there's actually 3 there, 2 of the points overlap, immediately we were getting reasonably accurate results. And it's interesting to note too, because the core had already been sampled, we did the spot analysis on the cut side as well as the round side. And you can see we're getting very different results depending on which side of the core we looked at. But eventually everything sort of came into where we wanted it to be. But it took a lot of analysis. And this is finely disseminated mineralization. We had another case study where it was coarsely disseminated, and we never got anywhere near accurate results. But the precision of the data, measured as a coefficient of variation, was very high for those spot analysis, whereas it was reasonable with the drag analysis. So just to wrap up, you really need to decide whether you want qualitative or quantitative data. If qualitative data will do, there's no point in putting together an expensive and time-consuming sample preparation and analytical program if really all you want to know are relative differences for your survey area. So the qualitative data are adequate for doing work on the fly and interpreting data on the fly and adjusting your sampling programs accordingly. But if you do, and I'm sure we've all seen press releases come out reporting portable XRF data, sometimes from companies that wish they hadn't done that. But if you are going to put it out, I don't have a problem with putting it out, but you do have to have a very rigorous program in place, and that's not an easy thing to do. And you have to question, why are you trying to replicate data that you would get from the laboratory? And sometimes it's just not going to work. In some cases, depending on the orientation of mineralization and drill core, it's going to be very difficult to get representative data. So I'll finish there. I have a few references that will be appended to the presentation, and with that I'll finish up.